Good morning, everyone. A warm welcome to all of you. I am Sudeshna Borosaikia and one of the moderators for today's event. I'm a postdoc and I'm a Lisa Meitner Fellow at the University of Vienna.
My warmest greetings to all of today's viewers from my side as well. Hello, everybody. My name is Maria Drozdowska and I'll be the second moderator of today's online discourse. I'm a research fellow at the Center for Space and Habitability at the University of Bern in Switzerland. And at the moment, I'm also honored to serve as the co-chair of the IAU working group of junior members.
So for today we have a very interesting talk. We're going to have a talk by Jocelyn Burnell, and she's going to talk about careering through astrophysics. So for those of you who don't know Jocelyn, I'll just give a brief summary of her experiences in astrophysics so far. And so Jocelyn Burnell inadvertently discovered pulsars as a graduate student in radio astronomy in Cambridge, opening up a new branch of astrophysics, work recognized by the award of a Nobel Prize to her supervisor. So she has subsequently worked in many roles in many branches of astronomy, working part-time while also raising a family. She's now a visiting academic in Oxford and the Chancellor of the University of Dundee in Scotland. She has been president of the UK's Royal Astronomical Society. In 2008, became the first female president of the Institute of Physics for the UK and Ireland. And in 2014, the first female president of the Royal Society of Edinburgh. She was one of the small group of women who had set up the Athena Swan scheme. She has received many honors throughout her career, including a $3 million breakthrough prize in 2018. The public appreciation and understanding of science have always been important to her, and she is in much demand as a speaker and a broadcaster. In her spare time, she gardens, listens to choral music, and is active in the Quakers. She has co-edited an anthology of poetry with an astronomical theme, Dark Matter Poems of Space. We're delighted to have you here, Jocelyn, and we are really looking forward to the discussions and the talk. So I think Maria has some logistical talk before that. So.
Yes, so the structure of today's event will consist of a 30-minute talk by Jocelyn, followed by 30 minutes of discussion. And during this discussion, we will address the questions that we received from those that registered via the registration form. Thank you very much for those questions. And of course, we'll also address the live questions that we're looking forward to receiving from everybody that's tuning in today. So hereby, we'd like to encourage everyone to ask questions. Please use the Q&A feature of Zoom for that. And if we run out of time, we will do our best to take note of the remaining questions and provide an answer later in writing. I think at this point, I will pass the floor to Jocelyn. So Jocelyn, please take it away.
Thank you very much indeed, Maria. Am I heard okay?
Yes.
Good, excellent. So thank you for the opportunity to do this talk. I'm very sorry we cannot meet in person. That would be much more fun, but at least there's Zoom for the time being. And my PowerPoint seems stuck. Right, okay. So I'm going to talk a bit about how I became an astronomer, a radio astronomer, a bit about the discovery of pulsars, and a bit about what happened after that. So I started life in Ireland, in the north of Ireland. They had an exam which all children took at age 11 because they believed by that stage they could be clear which children would have an academic career and which children would have a more practical career. And the education system split into two at that point, with the academic children having the normal high school experience and the other children being taught a lot more practical skills. I actually failed this exam, which wasn't clever, but my parents fought to get me in the academic stream, and they did. great fun moving into high school, having lots of different teachers, lots of different subjects. And in the first week, I remember the Wednesday, the first week of the first term, a message goes around the first year class. This afternoon, please, boys to such and such a room and girls to a different room. And I thought, Wednesday afternoon, it's sport. That's why they're separating us. They weren't. They sent the boys to the science laboratory and the girls to the cookery room, because everybody knew that girls were only going to get married, be wives and mothers and housekeepers, would not be part of the economic workforce, and therefore needed to learn how to cook and make beds and things like that. And apparently it was going to take 5 years to learn all that. I said I wanted to be in the science class. The domestic science teacher was not hearing anything of this. I told my parents that evening and they hit the roof and they phoned up the head teacher, as did the local doctor who had a daughter in my class, as did one other set of parents. And when the science class next met, there were 3 girls and all the boys. And I don't think that teacher had ever taught girls before. He made us sit right at the front up against his desk because clearly we were dynamite. We did physics that first term and I loved it and I came top of the class. I do not remember the teacher congratulating me. I do remember him berating the boys for allowing a girl to beat them. Next term we did chemistry. That was okay. Third term we did biology. We were given flowers to draw the flowers, label the parts, learn the names. And when you've done that flower, here's another one. And when you've done that flower, here's another one. And I thought, boring. And I'd had a prejudice against biology ever since. I went away to boarding school in England at age 13 and majored in maths and physics. Was good at a number of subjects, but those were the subjects I liked the best. All through this, I was thinking, I'm good at physics. I'm probably going to do a physics degree at university. What am I going to do after university with that physics degree? Where will I specialize? And I was thinking about the different branches of physics. And then I got to hear of astrophysics and thought, yeah, that's what I want to do. So I went to university in Glasgow in Scotland to do a physics degree with the idea of becoming a radio astronomer at the end of it. There weren't many girls doing physics, and in the 2 final honours years, I was the only female in a class of 50. And it was the tradition then that when a woman entered the lecture halls, all the men whistled, stamped, banged their desks, made as much noise as they possibly could. And it was one thing facing that, walking in with a group of women. It was another thing facing it, walking in on your own. And it also isolated me, rather. I didn't have any group to work with. So any problems I had with the undergraduate course, I had to sort out on my own. I did okay, and I ended up in Cambridge, UK, very much to my surprise, to do a PhD in radio astronomy. I tried to get into Jodrell Bank. They didn't reply. I thought they probably weren't taking women. I thought I was going to Australia, but the academic year in Australia does not begin till January or February. So I had a few months in hand, put in an application to Cambridge just in case, and very much to my surprise got in. So a little bit of British geography. I have my first 12 years or so in Northern Ireland at number 1. I then go to boarding school in York in the north of England, number 2. I then go to university in Glasgow at number 3. And there is some indication of the terrain on this map. You'll see I've been in the brownish areas, the mountainous, wicked, wild northwest. And then, to my surprise, I find myself down south at number 4 at Cambridge, where the land is flat and they speak with a funny accent. And it's a pretty rich part of the world. And everybody was very, very confident that I met in the university. Mostly men, but supremely confident. I'm sure most countries have a gradient. I reckon this is the gradient in the United Kingdom. And I had come from the area of uncouth savages to the area of ultimate civilization. And I felt very much an outsider on those grounds as well as gender grounds, very isolated. And I thought to myself, everybody here is very clever, and I'm not so clever. They've made a mistake admitting me. They're going to discover their mistake and they're going to throw me out. We now have a name for this attitude. I don't know what it's called in other languages, but in English it's called Imposter Syndrome. You are an imposter, an intruder, an outlier. You should not be there. And in bad cases of it, the student will say, I'd better leave before they throw me out. And within the first week, they are gone. Now, I had quite a battle to get there. I wasn't going to take myself home, but I did say they are going to throw me out. They will discover their mistake. But until they discover their mistake, I'm going to work my very hardest so that when they throw me out, I'll know I've done my best. Discomfort increased in the first week when all the new graduate students, except for 1 or 2 peculiar guys called theoreticians, when all the other grad students were given a set of tools. And this is my set of tools, I still have them. They are not delicate microelectronics tools, these are wire working tools. Because I was going to build my own radio telescope using a lot of wire. This is near the end of the process. We were building a telescope that would occupy 2.5 football pitches in size, 57 tennis courts. There were a group of 5 or 6 of us building it, and fortunately I was spared most of the sledgehammering. The guys hammered thousands of posts into the ground to mount the antenna on. I was given the job of dealing with all the cables and all the connectors. And here we are, I've put connectors on some low loss cable. You couldn't coil it up, it's air-spaced cable. You couldn't coil it up and take it indoors. I had to work outside. And one end of the cables went in that little red and white hut behind me. And very faintly in the distance, there's another red and white hut, which is where the other end of the cables was. And I've done all the connectors and now we are checking the impedance. I'm using a slotted waveguide and the man is my technical assistant, Don, who was a very conscientious worker, but did not like having a woman as a boss. This is the finished antenna, 2.5 football pitches, lots of strands of copper wire held up on the posts out of the wet grass. At that time, the University of Cambridge, the whole university, had 1 computer. It had less memory than your laptop, and it took up a whole room because it was built with vacuum tubes, not transistors. Very few people had time on it, and we did not. So our data came out on paper chart, and there was 30 meters of paper chart every day. And this is me analyzing some of those kilometers of paper chart, 5.3 kilometers in total. Now, I got used to identifying the quasars on the chart, which was my project. I got used to identifying interference, which was quite common as well. But there was a tiny bit of chart, about 0.5 centimeter long, where occasionally there would be a signal I couldn't classify. You can see it on the left-hand side of this diagram and some low-level interference on the right-hand side. And that's just a 10-minute strip of the chart. And you can see that the interference looks different from this signal, whatever it is. But it often wasn't there, and it was a very short piece of signal. I reckoned it occupied about 10 parts in a million of all the chart I was analysing. I showed it to my supervisor, who very wisely said, look, it only occupies 0.5 centimetre. We can't see what's going on. We need an enlargement. One way of getting an enlargement with this technology is to run the paper faster under the pen and everything gets spread out. But you can't leave it doing that permanently or it gets through the roll of chart paper in 20 minutes. So I made special trips to the observatory just before this signal appeared and made the high-speed recording. And it had disappeared. And I did it for a month. And I made high-speed recordings of receiver noise. Ultimately, I got it. And this is what came in. The trace along the middle is the signal from the radio telescope. The trace at the bottom is 1 second time marks. And you can see quite clearly the notation LGM1. You will be able to deduce that that was added later, quite a bit later, because of the number 1. You don't number something number 1 until you've got more than 1. When you've got 2, 3, 4. But LGM was my unfortunate nickname, Little Green Men, because it did look a bit like little green men signaling to us. My supervisor came out the next day, saw it with his own eyes, and began to believe me. We then got another radio telescope on the site with its own receiver to see if they could detect it, and they did. So my supervisor believed me a bit more. And then I found a second, a third, and a fourth, and the supervisor really did believe me by then. That telescope didn't find many more. I think it found a 5th one after I'd stopped using it, but I found the first 4. We wrote the paper up for Nature, and just before it was published, Tony gave a colloquium, which everybody came to. Fred Hoyle sat in the front row, and at the end of Tony's colloquium, when Tony said he thought it was a white dwarf, an oscillating white dwarf, Fred Hoyle spoke up and said, I don't think it's a white dwarf, I think it's a neutron star. And he turned out to be right. And he'd come to that conclusion within 40 minutes during the talk. It's pretty clever. Interviews by the press were disconcerting. They wanted to know how tall I was, what my bust, waist and hip measurements were, how many boyfriends I had, what pop group did I like. And the photographers wanted me to undo some more buttons on my blouse. It was all pretty horrible. But it was one science correspondent who coined the name pulsar. And so pulsars they've become. And it's now, for instance, on a t-shirt. And you probably know what they are, but just in case you're a little puzzled, highly magnetized rotating neutron stars, magnetic field offset, and somehow a radio beam coming out from the poles of the magnetic poles. And if the beam shines in our eyes, we see a pulse. If the beam misses the Earth, we don't know it's a pulsar. I got engaged to be married between discovering pulsars 2 and 3. And a lot of my friends outside of the university were congratulating me on my engagement, but didn't say anything about making a major astrophysical discovery. Maybe they didn't understand it. The journalists' attitude to young women scientists continued, and it was actually much more prevalent. I went for a job interview fairly soon afterwards, and the head of department said, "I don't approve of women working. It leaves nobody to do the voluntary work." And a few years after that, while staffing an exhibition about space science, a party of school children comes past with a teacher or a parent in tow, and they see the display and they say, "Oh, space!" And they all congregate round to look at the material and pick up leaflets. And the woman in charge says, now, if you all take leaflets, there'll be none left for anybody else. Perhaps only the boys should take the leaflets." And that's with a woman visibly staffing the stand. I got married as I finished my PhD. My husband worked in local government, and the way you get promotion in local government is to move to another area. So we moved to another area every 5 or 10 years, and I'm trying to keep my career going. A son was born 4 or 5 years later, and there were very, very few childminding facilities because mothers were not expected to work. In fact, mothers were discouraged from working. So I had childminding issues as well. When I went to my head of department and said, "I'm expecting a child, what maternity leave am I entitled to?" He said, "Maternity leave? Never heard of it." And he was right. The university did not have a maternity leave policy. There weren't many childminding facilities, and my neighbours were puzzled, to put it kindly. One saying to me, "You've got a husband, a new house, a new baby. You say you're bored. What's wrong with you?" So not much support there. So because my husband kept moving, we would try and move to a place where there was an astronomy or space science institute where I might get a job, although I had no certainty of that before we moved. So my career, not really been a career, it's been a selection, a collection of miscellaneous jobs. And it felt a bit like this game of snakes and ladders, where I'd arrive somewhere, I'd get a job, I'd work my way up that astronomical institute. And then husband would say, "It's time we moved," that I got a job in another area. And I would slide down a snake and find myself at the bottom of another ladder. I've also had to change wavelength a lot. I started in radio astronomy. I went next to gamma ray astronomy. I went next to X-ray astronomy. I went from there to infrared and then millimeter wave astronomy. And then the marriage broke up and I was free to get a job that suited me. And I set up a group that worked in energetic binaries right across the spectrum. So I've been a researcher, a university lecturer, a tutor, a manager, a professor, a head of department, a dean. I've done public relations and outreach, as well as doing all those wavelengths. And a lot of life has been a case of hanging in there. I was one of the first 3 girls to do science in my school. I was the only female in my undergraduate class. As Sudeshna said in her introduction, I've been the first female president of the UK Physics and the Royal Society of Edinburgh. I'm the first female recipient of several awards. And I'm still reflecting on the cultural conditioning of my generation of women. We were encouraged to perceive ourselves as wives and mothers, being of service. We supported our husband's career and got our fulfillment vicariously through that. I remember my boarding school, the head teacher telling us one day we were being educated to be good wives and mothers. And then 2 weeks later telling us we were being educated in order that we might fulfill our potential. And she obviously thought those two were compatible. And I think my generation, at least in the Western world, is a bit at a turning point, because women older than me did not expect to have careers. Subsequent generations do, although still face a number of the issues that I faced. I've often been the most senior female in the place where I worked, so there hasn't been a role model or a mentor. And I've had to play the men. I had to play the men's game. And I have wondered what it's done to me, as it turned me into a wee man using Scottish dialect as opposed to a woman or a she-male. I'd be interested in your perspective on this last question. Can you remain true to your gender and succeed in a world that is still male-dominated? Above all, it's important to laugh, make a joke of it, often because there's not much else you can do. But I think I now see that scientific society is moving, albeit slowly, towards women, rather than women moving towards the male scientific society. So I think things are improving. I hope you agree, and I'll be interested in hearing your comments. Thank you.
Thanks very much, Jocelyn, for this really inspiring few 30 minutes. We had a lot of things that we learned today, I think, from your experiences as well. It was very inspiring. If it's okay with you, and then we will start the discussion session. Mm-hmm. And for the discussion session, we have already asked our audience today to post some questions. So we have a few questions that we have collected, and we will just try to go through them, and hopefully we'll be able to cover quite a lot of them within the next 30 minutes. So, so then I'll start with the first question. And the first question is a bit more towards studying astronomy and coming from limited opportunity and non-traditional career paths. Mm-hmm. So the first question is it easy to switch from a different field, for example, computer science or some aerospace engineering, to start a career in astronomy?
It's not easy, but I think it can be done. I think it's a bit like me changing wavelengths so much, because the different wavelengths use very different techniques and have different cultures. So I think it can be done, but it's quite hard work, and inevitably a dip in productivity as you learn the new area, the new subject.
Yes, indeed. So yeah, it can be done. So so the next question is probably about career stage. For example, how easy is it to have a career in astronomy, a professional career, if you start a bit late in your life? Let's just say you are not a fresh high school graduate, but later in life you want to start a career. So is it too late, or do you think that there is still a possibility?
I think there is still a possibility, and you bring a lot of useful skills and background and wisdom from the experience you've had in your first field. So in some ways you manage better, I'd say, through the PhD and postdoc stages because of that experience behind you. But it can be financially very precarious.
Yeah, so finally on this career studies related topic, so what kind of advice would you give to students and researchers from a country with very limited resources in astronomy? So can they develop the field any further, or is there any advice from your career that you can give them?
It might be an idea to spend a few years somewhere else in another country, partly to build up contacts between your country and that country, whichever it is. It is difficult. If there's a serious lack of money, you're forever finding workarounds because you've got no money or very little money. So that is tough. But the IAU itself is keen on developing astronomy worldwide, and there might be resources you could get from the IAU itself. There's a development office, for instance, if you're in a really poor country.
So IAU is an option then to start somewhere. So Maria, do you want to take on the next question?
Yes. So Jocelyn, a big thank you also from my side for your wonderful talk. There are also many thank yous pouring in on the chat for you. I think everybody really enjoyed your talk. Thank you. I will switch gears to supervision of students. And so by students, I mean bachelor students, master students, PhD students, and then also supervision of the more experienced postdocs. So what in your eyes would you say makes a good supervisor? How much support should you give your students? How do you provide this support?
Well, I have to start by saying that because of my peculiar career pattern, I have supervised 2 PhD students in total and no postdocs. So I don't have huge experience myself of this. But I think one thing that's important is that you are approachable by the student or the postdoc, and friendly, helpful and friendly, without actually doing their work for them. But it is also important to keep engaged. So if they are writing a paper, that you do read the drafts of the paper and give them comments back and that kind of thing. And if they have ideas, think hard about the idea, discuss it with them, see if there are any pitfalls that they have not thought about. So engaging with them is important. It's also very helpful if those students and postdocs can be part of a relatively large department, because then there will be other people to talk to if they need to, and there'll probably be quite a good program of colloquia, seminars, literature reviews, things like that, that are very helpful to a student or a new postdoc.
I would definitely also like to echo from my perspective the importance of community and good communities to surround you. It's important to not be isolated. What I was also wondering is, for example, what if you find yourself in the situation of a conflict? How can you best manage the conflict from the perspective of a supervisor, but also from the perspective of the student, which might be even harder?
Well, keep talking and keep listening is important. But sometimes conflicts get to a point where you actually need help from somebody else. And if there is a senior researcher working in a similar area with some knowledge of your area, it may be that the 3 of you need to sit down together and talk through.
So Dash, the next one's yours.
All right. So, so the next question, actually 2 questions that we have here are on academic careers. So, which is always a very key topic, I think, for early career researchers.
Yes.
So with the limited number of permanent positions and increasingly intense competition, do you think the current model for research career progression needs to be changed?
It certainly consumes a lot of nervous energy, doesn't it? Worrying about your next job and worrying about whether you're doing well enough and all that kind of thing. A lot depends on how much government funding there is. And I suspect with COVID, coronavirus, science funding may get reduced in a number of our countries. So it's, I'm not feeling wildly encouraging at the moment, to be honest. Cultivate contacts, I think, is important. Put yourself out there. Take up every opportunity to give talks and make yourself known amongst a bigger group of people. Run IAU Young Astronomers groups, for instance, things like that. Have your networks as big, as wide as you can. But yeah, I'm not at all sure where we're going on funding just at the moment, to be honest. This is such a peculiar time.
Mm-hmm. So indeed, it seems like maybe after COVID is over, we might be able to think a bit about how as a community we want to progress. That might be an option, maybe?
Yeah, but you're actually driven by the funding bodies, whoever they are. Not even senior academics have a huge amount of room to maneuver. Okay, they can decide they want to change the field they work in, but the money they get is often determined by outside bodies.
So government policies then also dictate a lot how much our field progresses and how the younger generation can progress as
Yes.
well.
I think so, yes.
So in that note, what kind of advice would you give? I think you already mentioned a bit about what kind of advice you would give to early career researchers, for example, network, keep pushing. Do you have anything to add for people who want to go into industry? What if they want to do a slightly different alternative career path?
I don't have personal experience of this, but I think a lot of the same things will apply. You know, network, keep up your contacts, talk with as many people as possible. And if you are in an academic institute, there may be links with some industry, or at least there might be a career service that could offer some advice. They might have contacts with industry.
Yeah, thanks very much. Maria, for the next question.
Yes, so perhaps I would still like to briefly touch upon what you had just mentioned earlier. So you mentioned the funding agencies. So how do we actually reach them, and how do we stimulate change at such a high level? For example, as early career researchers, what can we do?
What kind of change are you trying to stimulate? What are you thinking of, Maria?
Anything that would alleviate the funding troubles that many of us are experiencing, and so many funding opportunities being highly competitive and so few succeeding from a large pool of applicants.
Right, yeah. I think the best thing you can, well, a funding agency has two different kinds of people in it. There will be academics who sit on committees that judge proposals. And there will be the civil servants, the mandarins, who run the organization. If you know anybody who sits on a committee, it would be quite worth talking with them a bit about how research councils function and what it's like being on one of the committees. Because I think behind that question is a rather naive assumption that you can influence a research council. I don't think you can. Can. I don't even think the academics that sit on a committee have much chance of influencing a research council. But get a better feel for what a research council is, how it works, by talking with some of the people who sit on their committees.
Thank you very much for that. So earlier you also touched upon about internationally moving to get more experience. How do you think this can be achieved, taking into account the current situation and all the travel restrictions that are in place that are going to make this so much more difficult? What can we do on top of this?
Well, there are travel restrictions, but they're not complete walls. You just have to be patient. I listened to a colloquium yesterday by a young Dutch astronomer who will be moving to Oxford in a few weeks' time. So he's moving from the Netherlands to Oxford, England. It is possible to move at the moment, although it's difficult with COVID, I do accept. And you might have to quarantine when you arrive for a bit, something like that. If we get a bad second wave, which we may be getting already, and we go back into lockdown, then nobody's moving anywhere, but people will understand that. And even if you're due to move, I'm sure people will understand that. So I think moving is a good idea. If you have a family, it's difficult because there's other people to think of, but it's good to get experience of different institutes. I wouldn't actually recommend moving wavelength as drastically as I've done. I had to do it and I've made the best of it, but it's not that productive in terms of papers and research outputs. But yeah, you can still move, but it's difficult. It just takes patience. One other spin-off, the postdoc who's moving to Oxford said he had absolutely no trouble getting a house to live in because nobody's moving at the moment. Nobody's moving in at the moment. So, you know, there are some pluses.
Mm-hmm. So actually, I was also going to ask, do you think that the pandemic will have lasting effects on the field, whether they are positive or negative?
Yes, I think one of the issues will be, I suspect, reduced funding for astronomy, which is a negative. For a positive, because of doing things like this, we are building international connections that we would not have built to the same extent if we had been traveling to meet people. So Zoom and things like Zoom is enabling us to talk with people all around the world in a way that we wouldn't perhaps normally have done so. So that's interesting. And if you can, you know, keep the hours, you can join in Zoom talks all around the world.
Yeah, so yeah, at least there are some positives, so that's good to know. So the next one, I'll focus on women in science. So as you know, in recent years, we have had increasing number of women who have joined STEM subjects. Still, we are very far from achieving gender equity. And of course, I would like to know if we would like to know is what do you think are the key obstacles in achieving gender equity and how can we overcome them if we can? I hope we can.
The two-body problem is one quite difficult issue. Being in a place where you can both have good jobs really limits the number of places. And then if there are children, that's also a limitation which tends to fall more on the women even now than the men. More childcare facilities would be a huge help. I don't know how it is in other countries, but in Britain there are never enough childcare facilities. So I think those are probably the two things that I see as most limiting, most complicating.
So on that note, do you still think that it's that as a woman it's harder to, because you always hear these stories about the test that people do regarding whether it's two people, a female and a male candidate, and often they prefer the male candidate. Whether it's true or not, we don't know because most of the time we hear these news articles, we hear these stories. So do you think this has gotten better since your time, or is it still something that we need to worry about?
Yes to both. It has got better, but there's more improvement needed. In the UK, we have a scheme called Athena Swan, or have had, I think it's maybe fading now. And it was for a university as a whole, a university department, to look at the numbers of male and female and other sexes in their departments and monitor the progress of both and monitor the pay levels of them all. And it has shown pretty clearly that there is unconscious bias, which tends to favor the male, which does favor the male. And unless you're very alert, unless a recruitment panel is very alert to unconscious bias, it can be more difficult for the woman to get a job. That's undoubtedly true. But monitoring the statistics will show if there's unconscious bias. It's pretty pervasive. One of the examples that I'm having a bit of a campaign on at the moment, I don't know to what extent it applies in your language, your native languages, but you might like to think about this. Often when we have to fill out a form, we have to say what sex we are, you know, male, female, other, prefer not to say. And the order these are in is inevitably male, female, other, prefer not to say. That is not alphabetical order. Male before female is not alphabetical order. And that is unconscious bias. So I have a campaign on whenever I see one of these forms to get the two swapped over. It happened because one day I was filling out one of these forms and something at the back of my brain said, why do I always have to tick the second box? I want to tick the first box. Oh, I should be ticking the first box because F comes before M in the alphabet. So there's a lot of subtle things like that that we could well do with identifying, articulating, and correcting.
Indeed, I think I totally agree with you on that. So is there any advice that you would give younger scientists so that they can be conscious about these unconscious biases and they can also prepare themselves for an interview or probably in a job hunt or in their career as well?
So where to start on that one? One of the things that is now happening in Britain is people are so conscious that not enough women are getting recruited, for example, that when there are interviews, they look very carefully at the genders of the candidates. And if there's a gender imbalance, more men than women, they'll call more women to interview. There aren't that many young women. And the young women that there are getting called to interview after interview after interview. And they suspect it's to make up the number of female candidates and that the place has no intention of appointing them. So there's all sorts of spin-offs that we haven't fully thought through, and we have to keep watching these things and adjusting the systems to try and ensure they remain fair.
And
different in different countries. Yeah, sorry.
And by we, you mean not just some person sitting at the top, but we as a community?
Yes, we as a community. Yeah. Now the IAU's got, I think, alert to this. They have been monitoring the gender balance of IAU members for 20 years. And with the opening up to younger members as well, this is increasing the number of women, at least at the younger levels.
So I think now we are going to take some live questions, Maria, is that correct?
Yes, and we have many. So perhaps touching upon male, female, So it seems that you've had rather mixed experiences in your past. How do you avoid developing some sort of resentment towards male colleagues?
Yeah, that's a very important question. So you end up kind of an anti-male campaigner. I think having a sense of humor is immensely important. If you can't laugh about some of these things, it's hopeless. I think that's the main thing I would say, but it's also useful to occasionally be with a group of women of your own age and culture, because that can help you see what's serious and real and what's actually slightly crazy and funny.
So then I will move on to the next question. So what do you think is the key for overcoming the imposter syndrome? Is there any?
Well, knowing about it, recognizing it, labeling it for yourself is important, because lots of people suffer it. And I've heard people much older, you know, journalists saying, well, actually, they think all journalists and broadcasters suffer from imposter syndrome because you're only as good as your last article, your last piece. And here comes another one kind of thing. So, yeah, I think it's a much wider fact of life than we have recognized. I think probably a lot of people suffer it at some level. I think my policy of giving your best was probably the best way to tackle it, because you can't do better than your best. And if that doesn't work out, okay, it doesn't work out. But to run away because you think they might sack you is ridiculous. Don't do it.
So I think there are several questions that would like to know what kept you motivated through your career path and what empowered you, whether it was past experiences, and also perhaps how can early career astronomers empower themselves and cultivate their empowerment?
I very much enjoyed what I was doing. I have loved being an astronomer. It's a rather different subject at the different wavelengths. You know, going from radio to gamma is quite a big leap, but particularly with radio and gamma, you're dealing with the same galaxies quite often. It's the same source of photons quite often. But I'm not sure that I did keep empowered. There were frequent occasions where I thought, I'm going to fail, this is going to fall apart. I'm going to be leaving astronomy. Those kinds of thoughts. I think probably the most important thing is a degree of stubbornness. You know, I'm not going to quit. They may throw me out, but I'm not quitting until they throw me out. And even then, I may be just going somewhere else.
So there is a question on the topic that we discussed earlier as well about funding issues, for example. The question is on what about unionizing and getting more political to solve the funding and low grant success rate issue? Can we unionize early career researchers? Maybe you can be politically active in your own country?
But it's not just that the funding issue isn't just faced by early career researchers, the tenured researchers as well. Maybe it's not so drastic for them, but they also need money for research. So it's academia as a whole that, and that'll include research institutions in that. It's academia as a whole that has to, and I think working together is probably a good idea. Unionizing, I would have thought we were reasonably unionized. There is the IAU, there are astronomical bodies in most of the member countries, maybe several different levels, you know, professional and amateur. And a lot of us work in universities. I think actually the biggest issue is convincing governments that astronomy is useful, because they'll only fund things that are useful. They won't fund blue skies research much. They will a bit, because they know that occasionally from blue skies research comes something incredibly useful. But I think it's demonstrating that there is useful technical training in your subject, that there are spin-offs and things like that. I think that's the way you get more funding.
So Jocelyn, you've mentioned that when you first arrived to university, you felt that everybody was very confident and you thought everybody was clever. So it seems that the current climate, at least in some fields, there's definitely strong competition between groups, but also between universities.
Yep.
Do you think that this is healthy, or do you think that this is something that should be changed and we should join forces more often? And if so, how do we achieve this?
Yeah. I think as telescopes get bigger, more and more astronomers are collaborating to put in a joint proposal for time, for instance. And I see more and more joint collaborations between people in different universities, at least in Britain. And I think that is good. I think it also helps the younger researcher. It means that, your post here is coming to an end, but actually you've got quite good links with that university over there because we work together on studying such and such a source with that big telescope. And so that gives you a better chance of getting a job over there at that other university. So I think the young people benefit a lot from collaborations between university groups. I suspect it's happening more and more, not least because the instruments and the telescopes themselves are getting bigger and bigger, and it takes a number of research groups to work together to achieve it. So I think it is happening, and I would commend it. I think it's great.
So the next question that I'll ask, I think it will be the last question for today because we are running out of time. There are plenty of very interesting questions. So as Maria said, we'll try to answer them at a later stage, and hopefully they will be answered soonish rather than later. So before we wrap it up, is there, what can you give as one piece of advice for your younger self if you start your astronomy career again in 2020?
Mm-hmm. Hang in there, you will make it. It'll be a very peculiar career pattern, but you will make it and you'll actually have a lot of fun and get a lot of different experience.
That definitely does sound nice. So Jocelyn, thank you very much one more time for your time and for your talk and for sharing your story with all of us. That has been greatly appreciated by us and the audience. Thank you very much. I think there would be a lot of applause sounding off right now.
Thank you very much to all of you. Thank you.
So I would also like to thank everyone for tuning in. And I'd like to remind everyone that next week, we also have another one of these online discourses. So please tune in next week, Thursday, October 29th, for a talk by the ECA Director General, Xavier Barcons. And thank you all again and hope to see you next week.